Welcome back. Today we're going to look at Section 10.2, plane curves and parametric equations. So the idea here is we're still going to have a curve sitting in a plane. However, if we introduce a third variable, so if we're in a plane, two variables, generically x and y, if we introduce a third variable, we can think of it as time or sometimes as an angle. We can get not only a picture of what a curve looks like, but what direction a curve heads in as it's being formed. So for example, if we consider x squared plus y squared is 3 squared. So this is just a typical two variable equation, and we're just looking at a circle centered on the origin, and a radius of 3. So we're just going 3 units in each direction. So 1, 2, 3 left, 1, 2, 3 up, 1, 2, 3 right, and 1, 2, 3 down. And just give it the old college try on getting a smooth circle. We can get a graph that the end result looks the same, but again has a direction to it if we introduce, in this case, theta as our third variable. So if we consider x to be 3 cosine theta and y to be 3 sine theta, we can try out various values of theta and just sort of trace the graph as it forms. So cosine of 0 is 1, 3 by 1 is 3, sine of 0 is 0. At pi over 2, cosine of pi over 2 is 0, sine of pi over 2 is 1, 3 by 1 is 3. At pi, cosine of pi is -1, 3 by -1, -3. Sine of pi is 0, 3 pi over 2. Cosine is 0, sine is -1, 3 by -1, -3. And then at 2 pi, we're back at the same output as before. So let's make a quick sketch of that. So we start at 3, 0. We could have tested several more. I just wanted kind of the compass points to get us going. And you can confirm to yourself that if you substitute these in, x squared plus y squared will indeed still give you the 3 squared. So here's where we start. At pi over 2, we're at 0, 3. So that means not only do these 2 points get connected, but we started here and headed in this direction. Same thing here at pi. We're at -3, 0. So that meant our curve continued in this direction. 3 pi over 2, we're at 0, -3. So again, continuing in that direction and then getting to 2 pi. Now we're back where we started. So this is a circle that is sort of formed by spinning counterclockwise. The end result is this is what's referred to as the plane curve. So a shape and a direction. Next one, we're going to let x equal t squared minus 5, and y will be t plus 1. So time and angles are the two kind of more common third variables to use. So we'll just try out sort of a handful of values here. And this one, this one we'll just find the rectangular equation. If you wanted to sketch a graph, you could plot several values of t the way we did on the previous example. So the rectangular equation as opposed to the parametric equation, we can get that in this case using substitution. So if we take the second equation, t is the same as y minus 1. So then x is the same as y minus 1 squared minus 5, and then just kind of expand that out. So x is y squared minus 2y minus 4. This would be the rectangular equation. So up here was our parametric. This is our rectangular. One thing to watch for in these when you're graphing, we do occasionally run into some domain issues. So if x is cosine theta and y is theta, well, we know one thing about cosine theta. Cosine theta is between -1 and 1 inclusive. And since cosine theta is the same as x, that also tells us that our domain, x has to be less than 1 in absolute value. Less than or equal to 1. As far as the y's, y can be anything though. And our relationship then, x is equal to cosine of y. So just another case of substitution. So this one, the one equation was already solved for the third variable. All right, so we'll do one more where we do a little bit of sketching. Yeah, a couple more graphs. So this one, x will be root t plus 3, and y will be sum of t and 1. So on this one, t has to be at least -3. And the reason there, we want to, if we're looking to graph this thing, the xy plane is just a pair of real number lines. If if t is less than -3, we're kicked out of the real numbers. So we can just make a nice little table for that. That also tells us that x has to be at least 0, since we're staying in the real numbers. And can do some little test points, or get the rectangular equation. If you want the direction, you need the test points. So t will start at -3. So square root of 0 is 0, and -3 plus 1 is -2. So 0, -2 is on our graph. Trying to get perfect squares under there. I'll try out a -2 next. Square root of 1 is 1. -2 plus 1, -1. So we have 1, -1 as well. Let's see, next perfect square would be a 4 under there. So t equals 1. Square root of 4 is 2. And 1 and 1 is 2. So 2 is on there as well. Next perfect square after 4 would be 9. So t equals 6 would be up next. Square root of 9 is 3. 6 and 1, 7. So we have 3, 7 as well. And that's all that's going to fit in our -10 to 10 grid that we usually use. So notice this kind of looks like half of a parabola, and our direction, we are moving from this point up and right. That should fit with what you expect to see from the rectangular equation. If y is t plus 1, then t is y minus 1. So x is equal to square root of y minus 1 plus 3. So x is square root of y plus 2. So that should fit the idea that we have the general shape of a square root graph, and it's shifted down 2. All right, so next we'll have a little fun with trigonometry and parametric equations. So some of the tools that we'll use in this, sine squared plus cosine squared is 1. Secant squared minus tangent squared is 1. And sine theta by cosecant theta is 1, things like that. All right, so this first one we'll look at x is equal to 3 tangent theta and y is equal to 4 secant theta. So tangent theta is x over 3. Secant theta is y over 4. So this one involves secants and tangents. So secant squared minus tangent squared is 1. So y over 4 quantity squared minus x over 3 quantity squared is 1. So that's from secant squared minus tangent squared is 1. Okay, so this format should look familiar. This is a hyperbola, since we have the minus on there. Okay, so some of the properties of this hyperbola. Because it's in the form of y squared minus x squared, we know that it will open up and down instead of left and right. We know that we have no shifting with the x's or y's, so our center is still on the origin. our vertices, we would go up and down 4 units from the center. So 0, 4, 0, negative 4. And our foci, so remember with the hyperbola, we have then a squared plus b squared. So 4 squared plus 3 squared. So f squared is 25. So this tells us f is equal to 5. So 0, 5, as well as 0, negative 5. So let's put what we've got so far. So here's our center, vertices at 4, 0, and negative 4, 0. Foci 5 each direction. And then if this were an ellipse, we would have gone left and right 3. So that'll help make our little box here. So I'm going to get our asymptotes in. And then we'll just figure out our direction on this. And we can just use a couple of sort of test points. If theta is 0, tangent of 0 is 0, and if theta is 0, secant of 0 is 1. So we're starting at this point. This is our starting point, 0, 4. If we let theta go to, let's say, root 2 over 2, or I'm sorry, that would be then pi over 4. Tangent is 1, 3 by 1 is 3. And our secant will be up here. So we're moving in this direction. And same thing down here. Again, we can find some test points to show that. They also do have us working the other direction with these, of starting with a rectangular and asking us to create our own parametric. So we'll do one for x minus 5 squared over 7 squared plus y plus 3 squared over 8 squared is equal to 1. So on this one we have the plus, so this one, our most, excuse me, our most useful would be cosine squared plus sine squared equals 1. So we're going to let cosine squared theta be x minus 5 squared over 7 squared, and we'll let sine squared theta equal y plus 3 quantity squared over 8 squared. We want to make this into a parametric, so eventually I want an x equals. We'll take the square root of both sides and we'll just use the principal root. So we'll say cosine theta is x minus 5 over 7. So 7 cosine theta is x minus 5. So the first part of our x equation would be x is 5 plus 7 cosine theta. So there's half of our parametric equation. Then we do the same thing with these guys. So we do the square root of both sides and use the principal root. So sine theta is y plus 3 over 8. So 8 sine theta is y plus 3. So y is negative 3 plus 8 sine theta. And that is your parametric equation. Notice it does need two pieces to it. How do you make the x's? How do you make the y's? All right. So in 10-2, I recommend 3 to 33 odd and 43 to 57 odd. If you have questions, get in touch with me. Otherwise, I will see you next time. Stay safe out there.